So in this problem here, we divide each one in its own term. So each term by 2x to the fourth power, and it'll be something like and this cubic root of x squared becomes x to the 2/3. Then it's easier for us to simplify the x's. So after we got this, we can begin with the integration. With this, we can move the x's up so they become negative exponents. After this, we can begin the integration. Here, instead of doing the division, we just flip the terms and multiply. Remember to always keep the negative sign. So now we can put the x's back where they belong. So this one goes down. And here, as we have two minus signs, they become positive. And we just simplify this term, so we get our result. This becomes cubic root of x to the 7th power plus c, always at the end.
The problem number 2 is the period of a pendulum is given by t equals 2 pi square root of L over g, where L is the length of the pendulum in feet, and g is the acceleration of gravity, which is 32.2 feet per second squared, and t is a time in seconds, and the pendulum, it says that it increases by 0.5%, which is 0.005. For the A part of problem 2, you are asked to find the change in the period of the pendulum if the original length is 4, so L1 equals 4, and so you need to find L2. To find L2, you'll need to multiply 4 times 1.005, which is the percent of change. This should give you 4.02. Now you're gonna have to use the delta y, which is you're gonna use 2 pi square root 4.02 over your gravity, which is 32.2, minus 2 pi square root 4 over your gravity. And this, if you solve it in the calculator, if you solve this, you should get delta y equals 2.22 minus 2.25, which should give you the change in the period, which is 0.005. Now to get B, it asks for the percent of change. To get that, you're gonna have to divide your change in your period over your original answer for your equation, which is 2.215 times x over 100, so that you can get your percent, which would give you 0.226%.
Okay, so now it's asking us to find on letter C the approximation in the percent of change of the period. So we have to derivate in order to get the change. So first of all, it's t. Well, we can get rid of the t. We don't really need it right now. So we have 2 pi square root L over 32.2. This is equal to g, which is the gravity. But I don't want any more variables. So we have 2 pi. And this is the same thing as having 32.2 square root L to the 1/2 power. So now we're going to derivate. We need to know that our dx is equal to 4.02 minus 4, and that is equal to 0.02, just for now. So now we're going to multiply, which is 1/2, and pass the L to the bottom. So we're gonna have 1/2, 2 pi, so I just switched them there, and over the square root of 32.2 L. Now that L, we know that L1 is equal to 4. So we're going to have 1/2, 2 pi over 32.2 times 4. Now all that times dx, and dx we know that is 0.02. Now when we put that in the calculator, and once we do that, it should give us 0.005%. Okay, so now for part D, it says to find the error in, well, what is the error in a day? And we know that one day is equal to 24 hours. and 24 hours is also 86,400 seconds. And that means, and I converted seconds because the problem is in seconds squared. So 400 seconds times the percentage, which is 0.005. So it's going to be times 0.005. And that should get us, if we get the calculator, $86400 times 0.005. And that should give us 432. 432 seconds is the error. So on letter E, it says to explain what D means. And it means that each day, the error of the pendulum is 432 seconds in difference. And that would be it. Okay, so on letter D, it says find the approximation of the error in the pendulum. So we know that our original was 0.226%, and the approximate was 0.248. So as you can see, they are not the same because the one is an approximation and the other one is the original. So that's why on letter E, I'm supposed to explain that one is the original, which is the 0.226, and the other one is an approximation, which is the 0.248. These are in percents. And that would be it.